In this illustration, we'll analyze a falling rod on ground. Here we are given that a thin uniform vertical rod AB of length L is placed vertically on a rough ground as shown in the figure, and its upper end is slightly tapped, due to which it starts falling. And on ground there is sufficient friction so that end B does not slip, and we are required to find the speed with which end A will strike the ground. Now in this situation here we can analyze if the rod starts rotating only about point B as it is kept at rest, and say just before striking the ground the rod is attaining an angular speed omega. Then in the situation we can see from the vertical position its central mass has fallen by a distance L by 2. So from the initial state we can write if the angular speed attained by rod when it strikes the ground is omega, then by work energy theorem we have initial kinetic energy of rod was 0 plus work done by gravity on it is mg L by 2 must be equals to the final kinetic energy. Here we can write as half its moment of inertia we take as ml square by 3 as it is rotating about one n multiplied by omega square. So simplifying this, giving us the value of omega is equals to root of 3g by L. Here if we calculate the velocity of an A with which it is striking the ground, then we can write velocity of an A is, this can be given as VA, which is L omega, that is L multiplied by root 3g by L. So this root of 3gl, that is the result of this problem.